Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Determine the member forces of AE and BC as well as the cable tension in DG. Cross-sectional areas are 1935 mm square for the horizontal truss members, 1290 mm square for cable DG, and 645 mm square for the vertical and diagonal members. Modulus of elasticity 200 gigapascals for both members of the truss and for the beam, and the moment of inertia of the beam is 1 to 50 times 10 to the 6 mm to the 4th. So here is the given problem. Then we will select DG as our redundant force. Let's call that F. Then, of course, at joint D, this is 0. Uh, then this is F, CD. Then you proceed to C. Show that solve for CE by summing up forces vertical. I will not go into the details of the statics. It's your job now so that you can also master statics because this is already structural theory. It is expected of you. So summation forces x, then you can derive 4f over 3 minus 60. You have color coding here because the members of the truss have different cross-sectional areas. So summation forces x, AB will also be 4f over 3 minus 60. Of course, BE is not a function of f. It is 90 summing up forces vertical. Then after that, you may proceed to A, summation forces vertical to derive AE, or you proceed to E. So show that this is 5/3 of F minus 225, and summation forces X at E, negative 8F over 3 plus 240. Then lastly, for member EH at A, summation forces Y, you will have negative F plus 135. So everything is complete. We now have sectioning in the steel beam, that's X. So negative Fx, or just make it positive Fx, because if you make it negative, the partial derivative is negative, so that is still positive. So partial of u with respect to f equals 0 equals integral from 0 to 9 of fx derivative x dx over e of beam I of beam, which is common for e is common for both the beam and the truss, members of the truss. If you make moment negative fx, then this is also negative x dx, so it's still the same. It's positive. So plus f times partial derivative of f1, length of dg is 4.5, area of dg is 1290, this one. Then plus the pink one, f partial derivative 1, the length is also 4.5. Then the area for vertical and diagonal members, that's why I color them with orange, is 645. So 645 OE. Then plus negative 5/3 F plus 75 times partial derivative negative 5/3. The length of this member is 7.5 over 645E. Then this is not included. This one, 5F over 3 minus 225 times 5/3 times 7.5 over 645E. Then for this member here, plus negative F 135 negative 1, length 4.5 over 645E. And the yellow ones, this one multiplied by 2. So negative this first, negative 8 thirds over 3 of f plus 240. Partial derivative, negative 8 thirds, the length is 6. Then area yellow, horizontal, and for horizontal members, 1935 OV. Then these two combined. So 2 times 4 thirds of f minus 60, derivative 4 thirds times 6 over 1935. So take note that we already multiplied by 2. So simplifying, so this one is f 243 over, so E is cancelled, common. So what is left is moment of inertia of the beam. And these values here are already multiplied by 1000 to the fourth for this term, divided by moment of inertia of the beam. So this is the simplified form, 243F over 1250. For the second, this is already multiplied by 1000 square. So 4.5 times 1000 square over 1290, or 4.5 divided by 1290. So that's why you have the 3 over 860, 3 over 860, this one. It is at least just this one multiplied by 1000 square over I of beam, because supposedly this is multiplied by 1000 to the fourth, then all these succeeding terms are multiplied by 1000 square. So we cancel 1000 square for all these succeeding terms, and since this is 1000 to the fourth, the net factor in the numerator is 1000 square. So integral of alpha x square 0 to 9 is 243 times 1000 square, then divided by I of beam, which is 1250 to the 6. So that's why you have there 243 over 1250. So this is 1000 multiplied by 1000 square, and the rest are at ease only. So for the next, we have 3 over 430, this one. For the next, except the constant, because we transpose it to the right later. Then this one is 25 over 774. This one is 25 over 774. This 5 thirds here. Then for this F here, negative, or 4.5 over 645 is, we have 3 over 430. And for this quantity, 128 over 5805. And this last here is 64 over 5805 equals, for the constants, we have these values: 125 over 86, 375 over 86, 81 over 86, 256 over 129, and 64 over 129. All these constants are negative, so that's why when transposed to the right, they become positive. So for instance, 75 times 5 thirds times 7.5, then divided by 645. So 125 over 86 for this. Then negative 225, 5 thirds 7.5, this is the result, and so on and so forth. they are all negative, so transpose to right, they become positive. So from there, we can solve for F. F is 29.84 kilonewtons. That's the force in member DG, and for CD, and since we are only asked for the member forces of AE and BC, so substitute for AE, for DG, 29.84 kilonewtons tension. For AE, this one, 5/3 of F minus 225. So 5 times 29.84 over 3 minus 225. Stress in AE is negative 175.3 kilonewtons, so it is compression. And for BC, 4F over 3, so 4 times 29.84 over 3 minus 60 is also in compression, so negative 20.21 kilonewtons. So that's it for this problem.